Researchers have made an exciting HIV breakthrough that's been described as a paradigm shift in understanding and treating the disease. The new findings by UMBC published in Science refer to the virus's RNA, where its genetic information is stored. They show that the virus's genetic code can be read in two different ways by cells the virus has infected. The result is that infected cells make two different forms of the virus's RNA. This functional diversity is essential for the virus to replicate in the body. So the virus has to have a proper balance between the two forms of RNA, Joshua Brown, the lead author on the study, told UMBC News. For decades, the scientific community has known that two different structural forms of HIV RNA exist, they just didn't know what controls that balance. So our discovery that a single nucleotide is having a huge effect is a paradigm shift in understanding how HIV works. What does this mean in terms of treatment? You can imagine that if you could come up with a drug that would target the genetic code at that one specific spot, and shift it to one form only, then it could prevent further infection, theoretically, Brown said. As well as making HIV drugs more efficient, the new findings could also reduce treatment to just one single form of medication, rather than patients needing several drugs to get the job done. If you're targeting a conserved region, you can potentially come up with a treatment plan that uses only one drug, said Aishwarya Iyer, another author on the paper. It might have fewer side effects and could offer more treatment options to people with different health conditions. The new research opens up a range of opportunities for Brown's research group and others. Every time we get a new drug in HIV, we exponentially improve the chances of individuals finding a drug that works for them, where resistance is a little less likely, said one of the paper's authors, Hannah Carter. Every time a new drug can get on the scene, that's a significant improvement for the lives of HIV patients. She adds that it could have a ripple effect throughout all of virology that impacts research into the novel coronavirus, too.